A while ago I was watching The Amazing Spider-Man 2 and I saw that Peter Parker had a gadget in it where he had a remote controlled car that he disassembled. He had the remote on his desk and the internals of the car on the door. When he pushed forward on the remote on his desk, it spanned one of the motors that was in the car, which span a bolt which unlocked his door. I saw that and I decided that I wanted to try and make it, but I also wanted to improve it. There are 3 issues that I have that Peter Parker didn't. 1, I live in student halls, so I can't drill holes into my door or change the lock or put any heavy adhesive or in any way damage the door. 2, my lock is a lot different from Peter Parker's. He has a bolt that slides horizontally, whereas I have a grip that you can rotate and turn. And the 3rd one is that because I'm living in student halls and not my parents' house, I can't leave my door open when I leave. So the lock has to be able to be activated from the outside as well as the inside. So I can't just have a remote on my desk. The mounting issue would be the easiest to solve. Because I have a 3D printer and I'm fairly used to CAD, I could take measurements of the door and print round connections so that I could tightly fit them on to the door, so that the whole mechanism could be mounted just through pressure, no glue or bolts required. There are 2 circles that jut out from my door, one's for the handle and one's for the lock, which would be perfect because it would mean that it would hold on securely and it wouldn't wobble left or right. The second issue, that my lock was different to Peter Parker's, I thought the best way to go about solving that would be to use gears. I could have the gear have a cutout on the inside that meshed perfectly with my door so that I could press it onto the grip and have a continuous servo motor turn in the gear. The 3rd issue would be the one that took up the most of my time and the one that I found the most challenging, that I needed to have the door activated from the other side. I thought of a few ways of doing this. I thought of RFID, I thought of using Wi-Fi, but I finally settled on using Bluetooth, and I think my solution at the end is fairly good and I'm very happy with it. The first thing I did before I did anything else was take accurate measurements of the door lock and the components that I knew I would have to have attach and fit tightly with my actual mechanism. My measurements ended up being vital to the project, and I used them many times throughout the development and in CAD modelling, and so I knew that everything would fit nicely together at the end. Now that I had a diagram of the door, I took some of the measurements and made a press-fit mount that would fit snugly onto the door. This was the easiest solution to find, and it worked almost immediately, I think with 2 test prints, and it has worked perfectly since. I knew I was using gears, but I didn't know what type of gear I would use in my final product. So I started out with bevel gears. The reason I used bevel gears was that I thought that the pressure applied into the door from the motor would mean that the gear stayed on securely and tightly and wouldn't shift about too much. So I started off by modelling those before doing anything else. I really jumped into the deep end with modelling gears, because I'd never tried modelling gears before at all. I knew nothing about gear modules, gear ratios, I didn't know any of the maths involved, I didn't know how to calculate whether 2 gears would fit together, and I started off with bevel gears, which really wasn't the easiest one to do. But after deciding on bevel gears, I managed to model some. I'm amazingly happy with how they turned out. They were a perfect fit onto the door lock, they worked flawlessly, they turned incredibly well, they meshed together great. After printing the bevel gears, there was an issue that I had that I couldn't have found out until I printed them. When the lock was in the vertical position and the gear was attached onto it, when pressure was applied from the bottom by the motor, it would pop the top of the lock off. And I couldn't have that on the final design because it ran the risk of skipping teeth. And if I was outside of the room while the teeth were being skipped, then I could be locked out permanently, and that would be a major flaw. Modelling the bevel gears wasn't a waste of time though, because I think it made me a lot better at CAD, a lot better at modelling gears, and it meant that the rest of the design process would be a lot easier. Since I couldn't use bevel gears anymore, I first had a look at using regular spur gears. I never modelled or printed any of these because after watching a YouTube video on a guy making a mechanical hydraulic press, I found something called a double helical or a herringbone gear. Herringbone gears have a few properties which would be very helpful in my project. First of all, they have slanted teeth, which means that there's extra surface area, which means that the motor can apply force a lot more effectively, and also there's less chance of the teeth breaking. Also, herringbone gears have another property which spur gears and helical gears don't, which is that all the teeth are in a V shape going the full length of the circumference, which means that the gears tend to centralize. They always want to be in line, they always want to be centralized, and they always want to be in contact on the edge, which is really good for what I'm using, for the purpose that I'm using them for. I don't want the gear slipping off the grip, I want everything nice and in line, and I don't want the motor falling out of the housing either. Herringbone gears are perfect for stopping this. Using the bevel gears, I was allowed to have the motor positioned vertically and pressed with the side of it against the gear. However, with herringbone, I would have to have the motor positioned horizontally instead, pushing into the edge of the gear. This means that the positioning of the motor would be a little off, and so I had to come up with a solution for that. I decided to kill two birds with one stone here by having the ball gear, the pinion gear, and then adding a third gear, which was a compound gear, a two-edged gear that had a larger gear that connected to the pinion and a smaller gear which connected into the bull. This meant that there was a higher gear ratio and the pinion could reach the gear without having to have a much larger gear. I had the compound gear use a 3D printed axle as a test, and it ended up working perfectly. I've had no breakages, it hasn't bent or ruptured, and it doesn't skip teeth either. I was really worried that a PLA axle wouldn't be good, but it's worked perfectly. I had to have a slightly wider diameter than I would have liked, with a diameter of the axle being 15mm, I think, but it works great, and I've had no issues with it as of yet. With the gears now sorted, I moved on to the electronic side of things. I knew that I wasn't going to be using RFID or Wi-Fi, so I instead looked at Bluetooth. The reason I settled on Bluetooth instead of anything else was because I messed around with RFID for a while, but decided that having the sensor on the outside of my door wouldn't be safe or secure, and since I live with 10 people, I wouldn't feel comfortable leaving my door like that. I tried Wi-Fi as well, with the idea that when my phone connected to the Wi-Fi network, it could automatically send a signal to the ESP32 or whatever microcontroller I was using, and that could activate my door in turn. So when I was in the building, my door was open, but when I left, it closed, which I thought would be very good. However, I would need access to the admin settings in order to do that, which I couldn't get because I'm living in student halls. The first thing I did was find a microcontroller. I knew I needed Bluetooth, and I knew that I wanted it to be small so that it could fit on my door comfortably. I ended up finding one called the ESP32 microcontroller, which was a microcontroller which was Bluetooth and Wi-Fi compatible. This meant that I could have it as a standalone piece and not need an Arduino on the door as well as the module. After messing around with the microcontroller for a while, I discovered that it had a few features that were very useful, and the thing that would help me out majorly down the line was that it was Bluetooth serial enabled. This meant that I could send messages from my phone to the IDE to the microcontroller itself, which was perfect, and it means that I could actually password lock my door. This is the 6th iteration of my Bluetooth serial password program. It's the one I ended up using and the one that I'm currently using. It works very well. I had many bugs along the way, but it finally works. I'll just talk through it quickly. These are the libraries that we used. This is me subbing the libraries. This is all the variables. This top section here is the setup of the ESP32 to allow for servos, and this section is just what is sent to the serial when the serial is first started. This section here is the functional bit of code. I'd call it the actual lock section of code, and it checks to see if the password has been entered and reacts accordingly to what has been sent. So it initially checks to see if any information has been sent to the serial. Whatever information is sent, it then sets as the input. It then sends some stuff to the serial, but then it does the checks. It checks to see if the input password equals the unlock password. Then it checks to see if the door is already locked. If it is locked and if it checks to see if it's already unlocked. If it is already unlocked and you're trying to unlock it, it sends a message saying it's already unlocked. This section is the section that runs when you're trying to unlock the door if it's already locked. It says that the door is unlocking before telling the servo to go at a certain speed for 4,500 milliseconds. It then puts the servo in a stationary position, says that the door is unlocked, and then sets the locked variable to false, saying that it is not locked. The input password is then set to nothing so that the whole loop can be started again. This section of code down here does the exact same except for locking rather than unlocking. Since I had my measurements taken, my coding complete and the gears done, I could finally assemble the mounting board. It was easy enough to do, and I can explain the features now. This section here in the bottom right is for the ESP32 to sit so that its pins have a place to sit and they don't bend. The square box with the hole in it is for the servo to sit so that the wire can stick out of the front. The long axle is the axle for the compound gear. The bottom I reinforced a bit more just so that it wouldn't bend or snap. And then the two holes are for the door, to mount onto the door so that it doesn't shift or pull off the door too much. Now that I had everything prepared, I could finally assemble everything. I'm amazingly happy with how this turned out, and I can't wait to make a Mark II. Thanks for watching. Hello there. I've just been doing the editing for the video, and I've realised that I mentioned the Mark II, but I didn't talk about what I actually was trying to do with the Mark II or my ideas for it. So I had the idea that rather than the ESP32 waiting for my phone to connect and then waiting for a password, instead it checks to see whether or not my phone can connect, whether my phone's in range. And so it would do that by searching for the MAC address or the beacon location in my phone. So say my phone was giving out the name Joel's phone, it would sit there and repeatedly scan looking for Joel's phone. If it scanned if it found Joel's phone, it wouldn't connect to it, but it would say that the door was open, and the lock would unlock. I would then also have a manual lock or unlock button on the inside of my door so that I could press it and have the door manually locked or unlocked. This would avoid me getting either locked in or locked out. I have had this idea for a while now. In fact, this was the original idea I had, but I felt like a serial Bluetooth would be a much better proof of concept. And I made a flowchart for it, actually, right at the start before I made anything to do with the project. So I thought I'd show that off. But this is where the project will go. I just need to do a lot more development on it when I get some time. I just want to say thank you very much for watching. If you made it to the end, then I'm amazed that I kept your attention for that long. Yeah, take care.